and then it does a loop all the way around the top. So I've picked up a Gameboy Pocket. That's not working, not coming on. It looks like someone's already had a go and done some reflowing on the power switch there. It's got missing battery terminals. I've got the speaker, and it looks like someone's been perhaps filling in the wires with solder, I'm not sure. There's some corrosion. We've got some corrosion on the wires on this side. This fuse, that's blown, that's not working. If I look at the DC jack, it's not passing the negative signal from the battery terminal to ground on the board, so that needs to be addressed as well. Now, while I've been a little bit unwell, I have been doing some animation. So today I'm going to demonstrate where the positive voltage lines come from the battery to the fuse, to the switch, to the DC converter and around the board, and we're going to use that information and we're going to see if we can bring this one back to life. Stay tuned. Okay, right, so here we've got a little animation. So this is the negative rail from the battery terminal, and it comes down to pin 3 and it goes through to pin 2 on that DC jack. So that means when you plug in a DC external power supply, it disconnects the batteries between pin 3 and pin 2. If your DC jack is corroded and you don't have connection between pin 3 and pin 2, with no jack in, the batteries won't connect. You won't get any power from the batteries. So on my board, I've already checked this and I know pin 2 and pin 3 aren't connected. So we'll have to look at that first before we look at the positive rails. So on a working board with no DC in, we'll get continuity. And on the faulty board, we don't have any continuity. So I've tried cleaning this out. So all I'm going to do is I'm going to bridge those pins for the time being. So we end up with a continuity from the negative terminal down to here, and that comes out onto this pin and it goes through to here on pin 2, and then it's in the ground plane of the board. So I'm just going to connect them with a bit of wire and test for ground, make sure all the grounds are connected up. So I'll just put a bit of fresh solder on. There you go. It's a bit ugly, but it'll do. Right, so with that done, we should have negative on the terminal, down to 3, across to 2, and it should, as you can see, it now goes to the different ground points around the board from the negative battery terminal, which is just what we want. So I'm quite happy that that part of the circuit is working fine. Now we're going to have a look at the positive, which is a little bit more in depth. So the positive rail comes down here and it goes to the bottom of that fuse, fuse 1. It comes out the top of the fuse and travels up the board to pin 1 of the on-off switch. Okay, so we should have continuity from the positive battery terminal all the way down to the bottom of this fuse. Yes, and out the top of the fuse, which we do, and it should go up to pin 1 on that switch, and it doesn't. So there's a problem somewhere from the top of that fuse up to the on-off switch. Let's have a look and see where it goes after that. you've got 3 volts going to the switch, and you have 3 volts coming out of the switch on pin C, and that travels back down the board to pin 1 on the DC to DC converter. Right, so let's check that. So from pin C on the switch, we should have continuity coming all the way down to pin 1 there, so that part's working. So let's address where it's going wrong on this board. I've been using these board scans, so as you can see, right, so this is the top of the fuse, and if I flip it over, it's now on the other side. It's here. This is the top of the fuse, and it goes up to 2 little wires here. So if we flip that over, those 2 wires are those 2, and then it travels up the board to there. So that's what the animation's been following. So we'll look at them too. So here's the fuse, and then if we go up, it's these 2 wires here, which I have continuity to the wire, but if I come up to pin 1 on this switch, it doesn't actually reach the switch, and it's because I've scraped away a bit of the copper there. If I go from the copper to pin 1 on the switch, it's there, but the wires are just corroded. They're not passing the voltage onto the copper. So all I need to do is to clean that up. It's these 2 that are together. I've just noticed something while I've been doing this. This is the power positive. It comes down to here, and then it goes to the bottom of the fuse there, and then it comes out of the top of the fuse, and it comes to these 2 here. So it's no good joining this one to this one, because you'll bypass the fuse then. So on the board, it's not this one. This is positive going to the fuse, and this one and this one, just under, almost underneath that capacitor, those are the ones that we need to work on, because they are coming from the top of the fuse. So what we'll do is we'll put a little bit of trace wire through from the other side, and we'll fill this one up with solder and put the trace wire on there, and then we'll test that. That's the one that we want. I'll just flip the board around, and we'll get that filled up with some solder. We'll get that trace wire tacked down. I'll flip that over. Let's just put a blob of solder on there. Right, let's try that. So I know that the positive terminal goes to the switch, and then eventually it comes back down to pin 1 on the DC-DC converter. So I could just go there and see if it works. But if there's a break somewhere, I need to know where it actually goes. So it goes to pin 1 now on the switch. So it comes out of the switch on pin C, and it comes all the way down to the DC-DC converter, pin 1. So that is the positive terminal connected up all the way down to here, which is great. So now let's see where things go after that. Right, so we'll follow this again up to pin 1, out of pin C to the DC to DC converter. Right, it comes out of pin 6 and it's putting out 5 volts, and then it does a loop all the way around the top. There we go. So it does a ring of power all the way around the top, and it connects up to pin 28 on the RAM, pin 10 on the regulator, which is this one, pin 14 on the LCD, pin 53 on the CPU, and pin 5 on the audio amp. So let's have a look at the main board and do pin 6. It connects to pin 28 on that RAM chip, pin 10 on there, pin 14 on the LCD connector there, and pin 53 on the CPU. So that's working fine, but this one is not working fine. So I've got nothing on that RAM chip, nothing on there, nothing on there. So there's a break from pin 6 up to this section of the board. So we're going to look at that next. So we can see from the animation there that it actually comes from here. This is pin 6, and it comes up to these two wires here. So let's have a look at those two. So we've got pin 6, and it comes up to these two here. Now typically what happens is, if your Game Boy gets wet, water gets trapped underneath this cartridge connector. You can see all the corrosion under here. So these two wires, I think, are shot. So we'll have to do something with those two. So that's our next repair. So I'll scrape away some of that. I'll pop some trace wire through. Change my mind. What I'm going to do is I'm going to put it through from this side, and I'm going to put it back through there, and I'm going to create a little loop which I'm going to solder to that copper there. I've just got a little loop. I'll put some solder on there. That'll be a nice little fix. Look at that. Perfect. Right, let's try that. So we've just hopefully fixed these, and there's the ring goes all the way around. It comes back down to negative here through a small cap on this side. So now we should hopefully have pin 6 to pin 28 on that RAM. And we do. And it should come up to here somewhere. And it doesn't. Try again. Yes, it does. The CPU. I think it comes to the regulator there. And the sound chip down there. So that part's sorted out. Hopefully. So what's next? It just keeps going. So now we've got the red line sorted out, the blue line and the yellow line. So what's next? One more. Pin 5. So pin 5 there is negative 18 volts, and it goes to pin 1 on the regulator, and that's for the extra voltage needed. I think it's for the LCD. Pin 1, pin 5, nothing. Am I doing it right? Let's just double check on this one. Yeah. Yeah, nothing. So the board might power on, but you'd get no input on the screen. So where does that one go? So that's this one, third pin. So that's pin 5, and it comes to here, which is this one. Comes to there. which is this one. So it comes to here. I'm choking. Comes to that capacitor and then up to there. We'll check it from that capacitor. So we're checking it from this capacitor to the top. No. We'll check from that capacitor. Yeah, so we're coming from the capacitor to pin 5, the regulator, so that's working. But it's not going from the capacitor up to the regulator at the top. And there it is there. Let's have a look at that. That's it. That little corroded wire. I'll put a bit of white vinegar on. I'm hoping it's the wire on this side. So I'm hoping I'll get a signal from there up to this one, VEE. And I don't. I wonder if I can just go from there, either through there or through here to here. It's this one here. I wonder what this hole's for. I wonder if I can just go through there from that, because it's from that cap through there, which is here. I don't know whether to come through here, but then I might foul these buttons if I can actually get it working. I think I'll just have to go scrape that away and then go round to here. So all I'm aiming for at the moment is to get the board hopefully powered on. There are some other signs of corrosion on the data lines, so I don't think it's a board that's I'm going to be able to get working unless I go through all of these. But all I wanted to do in this video is to demonstrate where the power lines go. Right, there you go, that's not a bad workaround. So that's just going from that trace around to the bottom of the trace there. Right, let's try that. So from pin 1, we should come down to here. And we do. Brilliant. And I think that's it. So I just need a couple of wires for positive and negative on the battery terminals there. And I'll pop that speaker back on. And we'll see if it actually boots up to a ping. So I'm a bit nervous now. I've got 3 volts on my power supply. So if I bring in this, I should have 3 volts. 3 volts at the fuse. Yeah. 3 volts up here. What can I do? So I'm going to switch this on. Have I got 3 volts down here? I do. I've only got 3 volts coming out of the DC to DC converter. I'm sure that should be 6. And 3 volts out of the DC converter there. That's strange. So is something not telling the DC to DC converter not to fire up? Because I've only got 3 volts. I'm missing the larger voltages, so I don't think that DC to DC converter is powering on. So I'm going to have a look at the schematic. I'm going to have a look and see if I can find out where the input, there must be some kind of signal. See, it's saying there VDD is 5 volts, VEE is negative 18 volts, and VCC is 3 volts. So that's why I'm expecting those voltages coming out of this DC to DC converter. It doesn't seem to have an input signal. There doesn't seem to be anything controlling it. There doesn't seem to be a signal for that going in, so I'm going to take the DC to DC converter off and see if there's any corrosion or any damage on the underside. Or perhaps in the past I've seen some of these little wires on the transformer have snapped, so I'll have to do that. Right, well, I'm not going to be able to pretend that I know what's happening on that circuit board. Those little wires sometimes get corroded and break, but they look okay. But if one of them was broken, I don't think I would get power. So I'm expecting perhaps a short circuit. I'm assuming these are little transistors. No, I cannot find anything wrong. I cannot see anything wrong with it, so I think that's okay. Right, I've got the converter back on. I've got 3 volts. I'm not getting 3 volts now though. 3 volts at the fuse, switch on, 1.3 volts. Down here, howie. 1.2. Am I getting 1.2 volts? 3 volts here at the fuse, 3 volts at the fuse, 1.1 volt at the top. So there's something not quite right. I think what's happening is I've soldered the negative onto here, onto this side of the board, but I don't think it's coming through properly to this side of the board because I'm getting no continuity to the negative pads on this side of the board to my negative on the battery terminal. So I think I need to pop a bit of solder in there just to connect that up, or take the wire off, push the wire through and solder onto this side as well. Just took a pad off. Shall we just solder the wire onto there, onto that side? Right, try that. Negative. Yeah, that's working better. Try this then. See where we go now. Right, now let's see if we've got some better voltages. Now I'm not getting any voltage at the switch. I've got voltage at the fuse and through the fuse, but not up to the switch, which I did have before. I think once you start putting power through the boards, it must increase the corrosion somehow. These are the wires for the power from the fuse, so I might have to put another little wire from here round the side and join it up to here. It's definitely going to be an experimental board. So from the fuse up to pin 1. Yeah. So from the fuse to pin 1 to pin C, back down to the DC to DC converter, pin 1. So that should actually come from my positive in all the way to there. Brilliant. Right, let's try again. Try these voltages again. Right, I should have 3 volts coming in, and I do. I've still only got 3 volts coming out. So there must be something controlling this on the outside of the board. And I have a hunch it's this regulator chip up here. Now I'm really stuck. Right, well, I stopped recording there, and then something's just gone short. Because the power supply went up to 2 amps. And the voltage dropped all the way down. So something has gone short circuit. Oh, I think I've worked out what it is. Has that come off? I'm not having much luck with this. I think what I'll do is I'm just going to solder that onto the top up here out the way. Right, switch that back on. I can't see it making a difference. 3 volts. Oh, it does make a difference. 5 volts. It's minus 18 volts. So the problem all along was not having a good negative connection on the battery terminal here, because it's all corroded away. But now that I've got a good connection up here, that's actually switched on. I wonder if I can hear a ping. No, I can't hear a ping from the speaker. I did measure the speaker and it measured 8 ohms, 8.9 ohms. So I think the speaker is okay. It could be the headphone jack. Let's plug a screen in and see if we got anything on the screen. I wonder if I can just do it this way. This is great. So my work is actually right, but I just didn't have a good a good negative connection. Switch on. Switch the power on. Nothing on the screen. Strange how I haven't even got a light on. Well. So if I go to, that's me 5 volts to the CPU and the screen, although the screen should have negative 18 at some point in there. So at least I know it's doing something. Now it gets very interesting. Right, I'm just looking at why this LED doesn't come on. And I think it's because this trace is corroded here. I should have continuity from this test point to the LED, but I don't. So I'm just going to replace that trace and then I'll keep on going. Right, I've just put a little wire on there. And hey, it's a small victory. I can't imagine that being the fault of why it won't come on properly. I've tested for the voltages on the chips, and I've tested the crystal there. That's putting out the right amount. I'm pulling 0.04 of an amp, 44 milliamps. I'm going to put a game in and see if it pulls any more current. And it doesn't. 0.045. One of these is volume. The other thing I can try, I've just started checking the bottom of the RAM chips. So pin 15 goes to the CPU. Pin 16 doesn't. It should go to pin 21, but it's not. So I need to look at pin 16. 17 does. 18 does. 19 doesn't look like it does. I've made a list of all the bottom pins on the RAM, which is here, the corresponding pins to go to on the CPU. And there's 1, 2, 3, 4 not going. And it's because I suspect of these corroded wires down here. So they'll go down there underneath the cartridge slot, and that's all the corrosion underneath there causing problems. So I've got 4 to go from here to 4 pins along the bottom here. So I'm just going to wire them up and see if it brings this thing back to life. I don't really want to go to the trouble of taking the game off, the cartridge slot off. I'm not sure if the work I've done already is worth getting this board back to life, but I did enjoy learning about the power rails up to now, but it would be a shame not to get a picture on the screen. Even if it doesn't play a cart, I'd like to get it, if I could get it booted up and get a ping, I'd be happy. So I think I'll just put 4 little trace wires from the bottom of these pins to here, and we'll see what that does. Okay, so I've repaired 4 broken traces. This is not how you repair broken traces. I've got 2 going across the top and the two on this side go underneath to the corresponding wires just up here. Right, so is that it? Is my agony over? Is that going to switch on? I'll give us a beep. Again, it's just the traces underneath the cartridge slot. I don't really want to take the cartridge slot off because the board's not in very good condition anyways. But we'll give it a shot. Right, 3 volts. Switched on. I still haven't heard a beep. No. Still not quite there. I'll pop this screen in. Although if there's no beep, I suspect it's not working. Right, switch on. Nothing. Now it's taking 0.53. Oh, what? Well, hang on, what's happening here? It's on. It's on. Oh, hang on, what's happening? Am I going to get a beep or not? I got no beep. Turn the volume that way. Try again. No beep. Where's my hang on? Where's my speaker? Now this speaker connector is quite corroded. Switch off. Switch on. Still not getting a beep. No beep. Is it worth trying again? Oh, can't reach the switch now. I've got a gobbled Nintendo logo. Right, we'll try a bit of IPA. We'll pop it in there. I suspect those aren't the only wires that are faulty. So I can't say the switch. I'm really not expecting this to come on. Yeah, just gobbledygook. So anyways, I don't know whether to leave it like that, because the whole purpose of the video was just to show people where the power lines went, which I think I've achieved. But the problem is there's a lot of corroded wires at the bottom here, underneath there. So the only way to get that board working properly would be able to take that off and give it a good clean. Or do I just say, well, there you go, that's the voltage sorted out? I really don't know what to do. I think I'm just going to leave it like that. The only thing I would like to work out is why is the speaker not working? Because that is... oh, hang on. If the traces for the speaker have to come down through here and go through the jack, the headphone jack, they could be corroded underneath there too. But I should be able to hear a ping directly from the chip now that it's working. I'm sure 12 and 15 was speaker out. We'll use this little probe and I'll put that on 12 and 15. So that's on 12. I'm still not hearing a thing. Yeah, we've got 12 and 15, left out and right out, and speaker SP, which is pin 3. Right, that's pin 3, that's speaker, pin 3, turn on. Still nothing. That's the only thing bugging us at the moment. Not the fact that it's not reading the game. So volume control is on 8 and 7, left and right in. Where's the sound coming from? I would have thought it would have came from the main CPU, because over here we've got the headphones the speaker. We've got a volume control. Where's the sound actually coming from? Oh, here we go. Sheet analog audio, SO1 and SO2, left and right, on 27 and 28 of the CPU. 27 and 28. Right, try that. There we go. Right. Right, so the CPU is outputting audio on pins 27 and 28. So it comes out here, which we've got, and it goes to SO1 and SO2 and analog audio. So we'll come down to, so we've got SO1 and SO2, and it does come to RA4. So after the resistor, it comes to, this must be the volume control, and then it goes to 7 and 8 on the headphone and speaker amplifier. Right, so this is 7, just off the volume. Oh, right. Right, we got a beep. So we've got the beep going into the audio amp, but we haven't got speaker out. I wonder if that chip's getting power. It says VCC on pin 4 and 14. Pin 4, 1, 2, 3, 4, which is that one. Doesn't look like it's getting anything on pin 4 and 14. 9, 10, 11, 12, 13, 14. No, not getting any voltage on there. Right, switch off. Right, and power off. So we'll go through that wire there, because that's pin 4. And it comes up there, and it goes in there. Doesn't seem. Oh, so that's pin 4 and 14 then. Is it? 10, 11, 12, 13, 14. Yeah, right. So how's the power getting into pin 4? Look, comes along here and then hits that. There. It's that there. That one there. It's just above that little hole. What there? That one. So I'm not getting sound because that wire is kaput. So that's pin 4 going to pin 14. That's the corroded wire that I need. VCC. If I just scrape off there. And we'll pull this through from this side. And we'll fill that wire up with a bit of solder. So my understanding is that should go to the fuse, and it does, because it's powered directly off the batteries. Right, so I've cleaned out the headphone jack, and if we turn on now, there we go. So the speaker is working. Now before I've cleaned out the headphone jack, I couldn't use me little speaker probe on pin 3. So I'm going to double check that now and see if it was the headphone jack that was making it not output. I'm on the wire next to pin 3. There we go. So you can connect an external speaker to pin 3, but it does depend on the headphone jack's got to work. And that's it. Brilliant. So that's it for today's video. It's been a bit longer than what I expected. I'm very happy that the video animation worked very well, and I hope that helps some people out. It was a little bit more involved because I had to do the traces from the RAM to the CPU. But that's quite common on these handhelds because, like I say, water gets in there. And you've got to take the whole thing off and clean it out properly. But I think I'll keep this board as perhaps a spare. If I get very bored, I might take the cartridge connector off at some point, but I cannot see it happening. Not for a Gameboy Pocket anyways. So that's it for the video. Thank you very much for watching. I'm over the moon that I've gotten that to boot up. Like I say, it won't read a game, probably because of the corrosion underneath that cartridge slot. But I'm going to leave it like that. Thank you very much, and I hope to see you all in the next one. Thanks for watching.